In this video, I'm going to show you the mechanism for how you hydrolyze an imine to a ketone compound. And basically, I want to show you that you can do mechanisms like this without worrying too much about it. Let's jump right in and attack the mechanism. In a previous video, I showed you that an imine, a carbon double bonded to a nitrogen, can be hydrolyzed. That means we added acid and water, maybe some heat, and we can turn that into a ketone. But what if somebody asked us, what is the mechanism? How do you do this? What's the step-by-step movement of electrons with all of the arrows in order to make this happen? And there might be like 8 steps. And how can I memorize all 8 steps? So the key to reactions like this, to mechanisms like this, is to not panic. The key is just realize that if you follow a few basic principles, you can figure it out. Just go step by step, work through it a few times to get confidence, to gain confidence in that you can do it. So here's how you do such a mechanism. Anytime you have an acid in there, you're going to protonate this compound somehow. Where does the H plus going to go? Where are you going to protonate? So in my mind, I just say something like, I'm going to protonate because it's in acid, and then I'm going to go to town. That means this part is how I gain confidence. I'll figure it out. I'm just going to protonate it, get it started, and then I'll go to town. I'll figure out the rest of it. So when I look at this and I say, okay, I need this to react with H+. Where's the most negative spot on this compound? Well, it's this juicy pair of electrons on the nitrogen. So they'll go grab that H+, and that makes a nitrogen with 2 hydrogens and 0 lone pairs. So this nitrogen has a plus charge, a plus formal charge. So I'm just going to keep protonating this nitrogen until it falls off as NH3. And I'm going to get an oxygen on there from my water. So I get something like this. Now here are the rules. Go to +1, back to neutral, +1, back to neutral. Just don't ever let it get to +2 because that would be too unstable. So here's a +1. So what can I do next? Well, I could let my water come attack this carbon and move the electrons up to nitrogen. You could do it in one step. If you don't want to do that, you can draw resonance forms whenever you like and say, all right, let's see, this wants electrons, this nitrogen. Here's some electrons, the double bond. Let's move those up onto the nitrogen. So now my double bond's a single bond. I have a lone pair on the nitrogen. These carbons are still here. And I have a plus on that carbon. Now we can let the water come in. I need to give it an oxygen on this carbon right here, so we'll let it attack. Then let's see, I have NH, H. And my water attack, there's 1 lone pair left, a positive on that oxygen. Now, the reason I didn't let this go grab an H plus first is that would have given me 2 positives. I don't want to do that. So I'm just going to go from +1 in neutral to another +1. Now let's see, the oxygen's on there. If the water falls off, it just goes back to here, so that doesn't help me. So what happens next? Well, I could let this go protonate, but then I'd have 2 positives. I don't want to do that. So let's clean up this positive first. Anytime I see this, we should recognize, so I can clean it up with another water molecule. I can pull that hydrogen off, leave those electrons behind. Now I have this neutral compound. Well, let's protonate again. I need to get rid of this nitrogen, so that's the most negative spot. So now I have 3 hydrogens on my nitrogen. All of this is the same. A positive nitrogen. Let's let that leave. I don't want that on my final compound. I shouldn't have written all of this here. It's in my way. Plus NH3 if I want to draw that. So the NH3 left. Now this carbon's a positive carbon. Boy, I'm getting really close. I can draw a resonance form where those electrons go into there. Now look how close I am. I have all of this with one extra hydrogen. So another water can come and pull off that proton. These electrons stay behind. And that leaves 2 lone pairs on my oxygen, and I make my final compound. 1, 2, 3, 4, 5, 6, 7, 8, 9 different steps, 8 different steps. And I don't memorize any of them. All I know is I'm going to protonate and keep playing around with it and go to town until I get to my final compound answer. And the stress is low because I've done it many times. So I realize I can figure it out and do it. But I don't have to be a grandmaster and see the entire pathway before my eyes. Whenever you encounter somebody asking you for a mechanism, get it started. If you make a mistake, cross it out and try something else, but keep playing around with the electrons until you get to your final compound. I hope that helps you gain some confidence in being able to do mechanisms. Practice some of these on your own. Maybe go back and just draw these 2 compounds and see if you can go through the same thing. And if you get stuck, come back and look at some of my examples. This step right here was extra in mine. This one's extra in mine. You may not have it exactly the same with these resonance forms, but that's okay as long as you get to the final answer. Hey, subscribe to the channel so I can help you be more successful in organic chemistry.